Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Mathematics is full of such amazing facts. Some of them, we don't know, and if you have the aptitude to dig deep into different concepts, the beauty of numbers will emerge out. And that's what happens, when you study a particular concept in depth and then try to do some research on that. And so many mathematicians have given us such wonderful facts and amazing things in mathematics, which makes it so much joyful. So in this video, I have a very interesting and very important concept for all the school students and for all the competitive exams. Also, this particular concept of the Kaprekar's constant. So this is what I am going to take up, the Kaprekar's constant. We are going to try and decode the Kaprekar's constant today, and we are going to extrapolate it to some other numbers also. So an amazing thing coming up. So you need to watch the complete video to learn something new, and you can show it to your friends and they will also feel surprised. How is this happening? The Kaprekar's constant. So Kaprekar, he told us that if you take any 4-digit number in which at least 2 digits should be different, like it should not be like 2, all the digits are same, at least 2 digits should be different. So I'll take an example and just show it to you what the actual thing was. Suppose we have a number like 8258. See, at least 2 digits have to be different, okay? Now, using this 4-digit number, we'll make the largest number possible first. Like 8852. This is the largest number which you can make out of 8258. And subtract the smallest number which is formed from the same number, 8258. So 2588. Now what happens when you subtract these two? You will get 6264. Another 4-digit number. And now repeat this process. You need to rearrange these digits so as to form the largest number. Like here it will be 6642, and subtract the smallest one, 2466. In this case, the difference is going to be 4176. One more time, 4176. The highest number can be 7641, right? 7641. And subtract the smallest number the other way around, 1467, and see what happens when I subtract it for the third time. 11 minus 7, 4. Now 13 minus 6 is 7, and then 5 minus 4 is 1, and 7 minus 1 is 6. And here we get a special number called the Kaprekar's constant, 6174. Whatever number you start with, if you repeat these sequence of steps, you will always get to 6174, and therefore this number 6174 is called the Kaprekar's constant. Now let's dig deep into the concept and check whether even 2-digit numbers, do they also converge to the same number? Like 4-digit numbers are converging to 6174. Do the 2-digit numbers converge? Let's check. Suppose we have a number like 38. The highest number is 83, and if you subtract 38, the smallest number from that, you will get 13 minus 8, which is 5, and then here we have 7, so 7 minus 3 is 4. Now the highest number formed from 4, 5 is 5, 4, and the smallest is 4, 5 itself. And therefore the answer is 9. We get a single digit number 9. So does it happen every time? I mean, whatever number you take, do they converge to a single digit number, and that to 9 only? Let us check once more. Let us take a number like, how about taking 17? Now for 17, 71 is the bigger number and 17 is the smaller number. So 11 minus 7 is 4. And 6 minus 1 is 5. Oh, so we get the same thing. Here also I got 54. So 54 minus 45. Again we get the same number, 9. And this is bound to happen, when you take any two digit number, take the bigger one out made out of these two digits and the smaller one, subtract the two, you get another two digit number, do the same process again. Ultimately, you are going to converge the difference to 9. And see, a wonderful phenomena, right? But we need to further investigate this to arrive at any particular kind of conclusion. Let's see how about three digit numbers. Now for three digit numbers, the convergence will take place or not, it depends on the numbers which we are taking. Let's start with any particular number, three digit number like 318. Now if I take 318, the largest number which I can make out of these three digits is 831, and if I subtract the smallest number 138 from that, I'll just do it 138, so you get 693. Now let's do it once more. 963 minus 369. Let's try this. 963 minus 369, we get 594. Let's do it once more. 954 minus 459. It is going to give me the number to which all these answers are going to converge. 495. Now I put it in a rectangle here because if I do it once more, I will go back to the same step. You can check. 954 is the largest number and 459 is the smallest number. So after getting 495, the process stops here because I am going to circulate here only in this particular step. Now does it work for all three digit numbers? It will be very, very interesting to find. Let's check. Suppose I take a different number. See, I am doing all random numbers. That is why I am using a calculator to subtract the numbers so that we can rush through the three digit numbers. Let's take another one. How about taking 276? Now starting with this number, the largest number is 762 and the smallest is 267. So let's try 762 minus 267, and fortunately for me this converges to 495 in the first step itself. And now 495 is going to repeat. You can check once more. 954 minus 459, you are again going to get 495. So let's take one more different example, then we will go to the four digit number, the numbers which Kaprekar gave. Suppose I start with, let's take 1, how about taking 9, 819. So 981 is the largest number, 189 is the smallest number. Let's calculate the difference. 981 minus 189 is 792. Let's do it once more. Largest is 972 minus the smallest is 279. So what do we get here? 972 minus 279 is 693. And one more time, 963 minus 369. I think I have done it here. See, 594. And finally, once you do it one more time, 954 minus 459 is again going to get you the same number, 495. And so proved that all the three digit numbers which you start with, they are all going to converge to 495 if you follow the operations. So now let's look at four digit numbers. Here we have the four digit numbers and how many steps are required to get to that magic number 6174, which is known as the Kaprekar's constant. Here we have an example of a one step number like 4286. If I do 8642, the highest number, minus the smallest 2468, I am going to get 6174. So one step I got to 6174. Likewise 4673 is a two step number. Like the highest number here will be 7643 and the smallest will be 3467. Now when you subtract them, 13 minus 7 is 6, and then you have 3 here. So 13 minus 6, which is 7, and then 5 minus 4, which is 1, and this is 4. Now do it one more time. 7, 6, 4, 1, minus 1, 4, 6, 7. You again get the same number, 6, 1, 7, 4 in two different steps. Likewise, there is a 3-step number, 3, 5, 2, 4, 4-step, 5-step, 6-step, 7-step numbers. This is the highest number of steps you have to do to get to this number 6174. So now you can check different numbers. You can try taking any 4-digit number in which at least 2 digits are different, and you will see that these operations of subtracting the largest and the smallest will always lead you to 6174, which is known as the Kaprekar's constant. So friends, if you like this video, do share it with all your friends so that they can also know all these amazing facts in mathematics. Do like this video, and as soon as you like the video, you will get an option of hyping the video, wherein you can award points to the video and hype it so that it comes in the feed of other students also, and they get chance to see this amazing concepts Indians have developed. So thanks for watching this video. I hope you enjoyed. Do practice it and let me know in the comments whether this works for 5-digit numbers as well.